Hello again, Math 95 class. So I getting some more questions about graphing, and I thought I'm going to show one more problem on the how to work that through, and hopefully that will help with several other problems. So this is basically referring to 11.5 problem 27. I've changed it slightly. But there you should, when you graph your s of x, you should see a parabola, and the colors Desmos is choosing always depends on what it thinks of in that day. On that day, you can right click on it. No, you can click it on and off. Somewhere you can also, it used to be that you can right click on it and then it changes the color, but I can't remember that right now. Sorry about that. But you can toggle it on and off there. So you have different colors there. In this case, our parabola is red and our line is blue. And so Webwork is asking you 4 different questions. So we are going to start with A, which are the question of what are the points of intersection. And so intersection is different from intercept. Intercept is every time a function is intercepting with either the x-axis or the y-axis. So the red one has here, here, and here an intercept, and the blue one has here and here an intercept. Now, this is not what we are looking for. We are looking for the intersection between 2 functions. So where the red graph and the blue graph meet. And so if I click here, I see suddenly a gray dot, and I click on this gray dot, and I see another gray dot where they're both meeting. And those are my 2 points of intersection. So in A, I'm gonna also write on here, so for A, all you're asked to do is write those 2 points of intersection out. So negative 20, 30, and 5, 5 in this case. Now, always when we have a point, the first one is x, the second one is y, first one is x, second one is y. And that becomes important with what we do, because we will constantly look at x and y, and often at both at the same time for these kinds of problems. Now in B, what it is asking of you, it is asking you to solve s of x equals t of x. So you have 2 functions. So what would that look like? Well, and you will see later on, just given an equation where it's just written out like this: x squared plus 2x minus 10 equals negative x plus 10. And you're asked to solve. That means when we have an equation like that, and I encourage you to write it out like that, because then hopefully your training kicks in and you're like, oh, don't I have to solve for x, right? So here we are looking only for x, but we are looking for the x where, let me switch back to looking at using my mouse to point at things. I'm looking at the x where both the function values are the same. That means the y of function s and the y of function t are identical. Now, those 2 points happen to be our points of intersection, right? The points of intersection mean that both the x and the y for both functions are the same. So that means for those 2 points, our y's are the same, and what we then write down as our solution are the 2 x values. So x equals negative 20 and x equals 5. And in that work, we often write it as a solution set, or you're strongly encouraged to do that, where you use the curly braces. Ta-da. And then you write it like that. But both web work will take both. It will just remind you that the curly braces are the preferred way to do that. Yes, so this is for A and B. Now, if you want to think about this for a moment, stop the video for a second, because I will now erase this part. So I'm gonna click clear. Yeah, so I'm gonna do that. I'm going to write one more time our 2 points of intersection of -20, 30, and then 5, 5, because we'll keep coming back to them. Now, the next one in C, and that might vary for you. So on the one that I'm working for is basically S of X is supposed to be greater than T of X. So that's what we are looking for. Again, at some point, you might have that written as then, it all fills in. So I'm going to do that. 1/5 x squared plus 2x minus 10 is greater than -x plus 10. Again, that might help you just kind of make the connection that we are looking for x value. We are looking for all the x values for which this is true. So what are we trying to do here? So when we look, let me actually draw a line. So let me draw a line right here from this point to this point. And then I'm going to draw a line right here from this point to this point. So these are supposed to be straight vertical lines. They look a little crooked. My apologies. However, so right there, go straight down. Now, if I look here, right, these are both the same x values. So in this case, probably -22 is the x value for these 2 points. But then we have a y value for the red one is clearly bigger than the one for the blue line, because it's above it. So it's above it, it's greater. And so there's 40, and the other one was maybe 32, right? And so here the red line, which is our S of X, is greater than our blue line. Now that's what we are looking for. But here in this area, suddenly the blue line lies above the red line for any one x, right? I can make many straight lines here. I can make another straight line. Oops. No, I didn't want to. Oh, well, those 2 lines certainly didn't work as well anymore. Let me maybe, oh, there we go. That works. I have to watch that I don't accidentally use both fingers. So here for all those lines, right, it's clear that the blue line is greater than the red line. However, I keep going to the right, and oh, look at this. I again see that if I draw a straight line here, maybe I take this solid line here to help me draw a straight line. And again, my red line is greater than my blue line. So the areas where the red line is greater than the blue line is basically everything to the left, let's go here, the left of our point of intersection and to the right of our point of intersection. Hello? Not clicking. Oh, because I'm sorry, I'm on the wrong spot there. Here we go, right of our point of intersection. So that means the entire area here and the entire area kind of here, and then all of this going on to both negative and positive infinity. Now, it can make it for us actually in Desmos, where we can just type. So now I have to actually delete A. Let me not make it clear. Let me just erase A here for a moment. We know our points of intersection now. And then I'm going to draw, write S of X is greater than T of X. It doesn't work when you make an equal sign, but when you make an inequality, look at this, everything I shaded, now it shades it for you. And so you can see, oh, everything from negative infinity all the way until our point, click it away again here, our intersection point means, and now I only write X, negative 20, right? Because I'm talking about solutions. The solutions are always an X. And then union, because now I jump the middle part, and then I keep going on the right side, starting at 5, X equals 5, all the way to positive infinity. So that's what I need for this one. And Desmos can help you with it if you understand how it's shading it for you. And I made already, right, round signs around the negative 20 and the 5 because I only have a truly greater sign. And Desmos shows that to me by having dotted lines along the edges of the green. So this is how you get there. So this is for C. Now for D, it's usually exactly the other way around. So I'm gonna click this away all. Actually, I'm gonna delete this part. So I'm gonna delete our solution. I'm gonna write that this is D and just gonna change our signs here. So D now is asking us for S of X being less than or equal to T of X. Less than or equal to. And so now we are looking, so we want to change. So let's do it this time the other way around. We want to, I have to look at the laptop when I change that. So I'm using two devices here. So I'm just going to write less than and then an equal sign, and it automatically turns this into an equal, less than or equal sign. And I should also delete all my previous, well, this one I can actually keep there, but these ones I want to also delete. So if I again, right, I still have my straight lines there that help me compare. And now I want the opposite. So I want where S of X is below our line. So our parabola is below our line, and that's only for the middle stretch. So only for this middle stretch here, starting again at our point of intersection, all the way to our other point of intersection. For all that part is our parabola that's coming down here, less than our line. Sorry. So then again, our starting points are our X. So this time we have straight lines because with the points of intersection are included. So our answer is going to be negative 20 to 5. And so the tricky part here is that we look at how the Y's are different, and then so the Y's are different, but then we talk always when it comes to solution about the X. So that's why I highly recommend that you write that actual inequality where you plug in S and T of X out so that it reminds you we are solving for X. They're wanting to know for all the X for which this inequality is true. And so now we've captured them all. So I hope this is helpful. The other reason why I write out that actual inequality with all the X's is because after you've done a couple problems of like this, it will then just have you do some equations like that. And then you see now, you just type in, and just name them however you like, S of X, T of X, or good, or F and G. The left side is a function, and write it as a function with the function name. And then the right side of the equation, write it with as a function with a function name in a separate line. And then you can just have Desmos do a lot of the work even for you, right? So I hope that's helpful. And join me in my office hours tomorrow, Saturday from 11 to 1, or Sunday 3 to 5, or make an appointment. So if you have any questions and those times don't work for you, I'm happy to also sit with you one-on-one and help you walk through some of those problems. All right. Stop recording.